Good morning, professors, and hello, everyone. My name is Supatha Nawarat, and in this video, we'll walk you through our final project of the Computer Programming Laboratory class. There are a total of 6 tasks that we had to accomplish, which are the following. Number 1, connect our M5 stack device to the Blink platform. Number 2, creating an on-off switch for the LED. Number 3, reporting the status of the buttons pushed on the M5 stack. Number 4, reading the data from the DHT11 sensor. Number 5, displaying the data from the previous task. And finally, number 6, a function we create ourselves, which is what we call the temperature limit notification. Let's get started on task 1.
For task 1, we will be discussing how to control an Arduino remotely using the Blink application. In order to do so, there are a few steps we need to follow. First, we need to install the Blink library. This library provides us with a set of functions that allow us to interact with the Blink app. Once we have installed the library, we can begin using the provided Blink functions in our code. Next, we need to connect our Arduino to our home Wi-Fi network. We can do this by importing the code provided in the lab manual. This code will allow our Arduino to connect to the internet via our home Wi-Fi network. Finally, we need to provide our Arduino with necessary information to connect to the Blink app. We do this by providing the auth token from the Blink website. Moving on to task 2 of our project, we will be discussing how to control an LED using the Blink app. To do this, we will write a function that receives a value from Blink app and uses that value to control the LED. The value we receive from Blink app will be stored in the V0 variable. When we click the on button in the Blink app, the value of V0 will be set to high. When we click on the on button, the value of V0 will be set to high, indicating that we want to let the LED to turn on. When we click the off button, the value of V0 will be set to low, indicating that we want the LED to turn off. To control the LED, we will use the digital write function. This function takes 2 arguments, the pins we want to write to and the value we want to write. For task 3, we will be discussing how to use a button to control an LED and display the state of LED in the Blink app. To do this, we will use the m5.button.isPressed function to detect whether the button is pressed, and the blink.virtualWrite function to display the state of the LED. On task 4, we have to read humidity and temperature. In order to do so, we have to download simple DHT libraries to use its function. We use blink.virtualWrite to send temperature to our site and show it on Blink app. Moving on to task 5, we will be discussing how to report humidity and temperature readings in the Blink app. To do this, we will edit our Blink app to include a gauge widget, which will display the current humidity and temperature readings. We will go to the Blink app and select the Widgets tab. From there, we will select the gauge widget and drag it onto the screen. We can then customize the widget by changing its size, color, and range.
For task 6, we created a temperature limit notification system. The conditions are, number 1, if the temperature exceeds 32 degrees Celsius, the M5 stack will play a 3-note sound through its speaker, and the Blink screen will show the message too hot. Secondly, if the temperature goes below 30 degrees Celsius, the M5 stack will play a different sound, and the screen will show the message too cold. For this, we played around with different sound frequencies and delay time to create unique notification sounds.
Oh, wow. Too hot. Thank you for listening to our project. Bye-bye.